So, hello, welcome. Oh,
it's
Peter,
actually,
sorry.
Yeah, hello everyone. Welcome to this Men&Mice webinar. My name is Peter Petersson. Today's webinar is focused on PowerDNS, and it is Carsten Strotmann from the Men&Mice services team that is presenting here today. Please note that all attendees are on mute. However, you can submit your questions through the GoToMeeting control panel, and we can address these questions toward the end of the webinar. Now, please note also that we are recording this session, and you can find this webinar along with the slides at our website within a few days. And at our website, you can also find recordings and slides from previous webinars. So, Carsten, the audience is yours.
Thank you, Peter. So, hello, everybody. Welcome to our today's PowerDNS webinar, part 1. Part 1, because when I was preparing last week for this webinar, I found so much good stuff in PowerDNS that it was not possible to cram everything in 1 hour webinar. So we will have a second one in September with some remaining stuff. Today we have the overview. What is PowerDNS and what it is good for, and we will show the most popular backends, which is the bind backend and the SQL backend. Also have a look on the remote zone backend, which is some kind of a specialty, something that you cannot find in other DNS servers. And we will also have a brief look into DNSSEC signing with PowerDNS, which is also one of the really good parts of PowerDNS. I would say DNSSEC signing is very, very easy. And because PowerDNS is such a good product, Men&Mice now also supports PowerDNS in the Men&Mice. And I will show how that is working with the Men&Mice Suite DNS server controller for PowerDNS. So first, what is PowerDNS? PowerDNS, what I'm demoing here, is an authoritative DNS server. So it serves authoritative DNS zone data, meaning it's not a recursive name server. It hosts DNS zone data that is your zone data, and it's being queried by other people. It's not, at least not the product that we are demoing here, a recursive name server that would be used by your clients to query other people's DNS data. So an authoritative DNS server only. It's fast and feature-rich, so it's one of the fastest in the bunch, and it has a lot of good features, and that's the reason why I had to split this webinar in 2 parts. It has a fairly modern architecture, at least compared to some of the other open source DNS servers out there, and it's open source, it's GPL licensed and available on many Unix-ish platforms, meaning Linux, the BSDs, and also commercial Unixes like Solaris. There's also a different product called the PowerDNS Recursor, which is the recursive caching server from PowerDNS, which is a different piece of software. You can actually combine the authoritative and the recursive part of PowerDNS. We will cover the PowerDNS Recursor in a future webinar. This one is solely on the authoritative part. So PowerDNS is produced by the PowerDNS BV company, which is Bert Hubbard and his team, located in the Netherlands, and it dates back to 1999, when it started, and it has been developed over time and got more and more features and more people using it, and there was a bigger change in March this year when the PowerDNS company has merged with the Open Exchange guys, and they are now part of the Open Exchange team. And we'll see what benefits that gives for the customers and for the product. And as I already told you, it's open source license, it's GPL version 2. One unique feature of PowerDNS is that it has these pluggable backends. A backend is a store for DNS zone data. So they are not traditional backends, meaning backends like other DNS servers use, like the bind name server. So you can use bind zone files or RC1035 master zone files. You can even use the format of DG Bernstein's Tiny DNS, and you can also use the setup from MyDNS, which is a DNS server also using the MySQL database. You can use that database format as well. Then PowerDNS supports its own database schemas on a variety of different open source and commercial database platforms like MySQL, PostgreSQL, Oracle, SQLite, LMDB, and there's a connected to OpenDBX, which gives you then even more databases, like OpenDBX being an open database, SQL database driver. There's a GeoIP backend, which you can use to respond with different data depending on the geolocation of the IP address the query is coming from. That is heavily used for bigger installations where they want to distribute the IP addresses based on who's the query coming from. One bigger user of the GeoIP backend, for example, is Wikipedia, the online encyclopedia, and they have many sites and many web servers around the world, and depending on from where in the world you are sending a DNS query, you get back then an IPv4, IPv6 address of the maybe nearest data center with Wikipedia. You can store the DNS zone data in an LDAP database, and there are other very special backends like the Lua backend, Lua being an embedded programming language, which you can use to programmatically create DNS answers. There's a remote backend, which is a JSON RPC backend. So then PowerDNS will start one of your programs, give it the query in JSON format, and you can then work on the query and send back the answer also in JSON to PowerDNS, and will give that back. And similarly, the older pipe backend, which pipes the query to an external program and gets back the answer from the external program. Interestingly, the backends can be mixed. There are some limitations, but generally can do that. For example, you can have static zone entries from a bind backend or an SQL database backend, and then have some other record types being served by the remote, that is the JSON RPC backend, and they mix. In PowerDNS, if it receives the query, it will query each backend in order. The order is being configured in the configuration file until either it finds an answer, or the list of the backends is exhausted and then the data is not there. So depending on the query, either in NX domain or in server fail, or no data is being returned. Now, every time hitting a database or even the remote backend for every query would be slow, would be not the fastest name server in the world. Therefore, PowerDNS does some intelligent caching of the answers. You can configure that. So, but in general, you can say that an answer that was retrieved from a backend is being stored in main memory of the PowerDNS server. If the same query is being received again, then the answer is coming directly from the cache, and that's blazingly fast. So I prepared some demos, actually some demo videos, and in the first demo I would like to show you how to configure PowerDNS to use the bind backend. Now, the bind backend is for administrators that are familiar with the bind name server. So you can even use the bind configuration file. We will see that. Now, my demo machine is a Gentoo Linux machine, and the PowerDNS version I'm running here is the almost up-to-date version, 3.4.5. The latest version just came out last week, which is 3.4.6. And now we have a look at the configuration file, the pdns.conf. It's a very simple configuration here. PowerDNS can have its own supervisor process that takes care that PowerDNS doesn't stop, doesn't crash, and never restarts. We use a different system here, so the guardians don't know. We just have the bind backend. It's a master server. We have IPv4 and IPv6 IP addresses configured where the name server will be listening on, and the configuration for the bind backend is just 2 lines. It's the location of the named.conf file and a check interval of 5 minutes. So PowerDNS will check named.conf for changes and the zone files for changes every 5 minutes. And should there be a change, it will automatically reload the configuration or the zone. Here is the named.conf, and that's just a normal named.conf that you can directly copy from a bind setup. PowerDNS will not make use of any options or other ACL or server type configuration. It will just read the zone stances. Here I have already 2 zones configured, the example.com and example.de, and I'm adding the Men&Mice.info zone as a master zone. I pointed to the zone file, which is in the PowerDNS own directory, saving that file, and now I'm creating the zone file, and the zone file is just a normal RC1035 master zone file, setting the default TTL for the zone, save some typing, and then there is some SOA record, and with the usual fields, the master name server. Talking about master name servers, PowerDNS can be run in different configuration with regards of replication between master and slaves. There is the traditional master and slave setup with zone transfers, but you also can have also native replication, which means if you run an SQLite backend or a SQL backend, a general SQL backend, you can use the database own replication mechanism. For example, if you build a cluster of databases, then PowerDNS can make use of that, and it will be a multi-mill master system. Now I have a SOA record, NS record, and IPv4 and IPv6 record in my zone file. And because it's just a normal bind style configuration, I can even use named checkconf from the bind tools to make sure the configuration is correct. Here it's checking the named.conf plus all the zone files, all 3 zones loaded correctly, at least bind, and so will PowerDNS. And now I use pDNS control, which is the equivalent to RNDC from the bind side, which is a remote control program to tell the running PowerDNS instance to load the Men&Mice.info zone file. In the syslog output that is on the bottom of the screen, we see now that the zone Men&Mice.info has been loaded, and I can now fire a dig towards the PowerDNS name server, and we will see that the data is there. So first I'm asking for the SOA record of Men&Mice.info, and we will see that is exactly the SOA record as I've typed in. Next is the IPv4 address record for the .dub entry, and also that entry is there, and last is the quad A entry, and also the quad A IPv6 entry is there. So that was easy. The PowerDNS control or pDNS control time has some more features. Some examples here: we can query the uptime. We can use an rping to just check whether the server instance is okay and running. We get a pong back, everything is good. We can get statistics about the query types, that is the types of DNS queries being sent to the server, and we have seen here was 1 A record, 1 SOA record, 1 quad A record. Of course, on a busy authoritative name server that is in real production, you would see much more record types and much higher numbers here. So that was the first demo. Going back to the slide set, which I just killed. One moment. I'm back on track in a minute. So that was the bind backend. If you have any questions, please remember use the chat window or the question section, and we will answer them at the end of this webinar. The next demo is about the MySQL backend, and that shows how to configure PowerDNS to run against a MySQL database. So here we are. So we have MySQL installed here. Actually, not MySQL directly. We have MariaDB, which is the open source variant of MySQL from the original MySQL developers. And I start here with logging into MySQL and creating a database called PDNS, which will hold all the PowerDNS configuration and zone files. After creating the database, I'm filling the database with a default schema. You find default schema in the PowerDNS documentation. Actually, there's an SQL file that you can just copy and paste from the website, and you pipe it like I do it here into MySQL. And now the MySQL database is set up to host data. If you have already zone files in bind style, like I have here, you can use the zone to SQL command to convert the zone files from named.conf into SQL statements that will populate the database. And by default, zone2SQL prints these statements to the screen, and I'm piping that now into the MySQL command, so it then goes to the database. It tells me that we have parsed 3 domains, which were the 3 domains I've just created, example.com, example.de, and Men&Mice.info. Now I go into the PowerDNS configuration. I've changed the backend now to launch the generic MySQL backend. And we have the simple MySQL MariaDB config here. The database is on the same machine. User is root. Database name is PDNS, and the password is also PDNS here. It's not a production environment, so I can show you the passwords, no problem. I'm starting now the PowerDNS instance using runit. And it's now started, as we see in the syslog output at the bottom of the screen. And now we can use PDNS control to list all the zones. And we see we have the example.com, Men&Mice.info, example.de zones loaded here. And now I send a dig to my machine, asking to my PowerDNS, asking for www.Men&Mice.info, and still I get the IP address. But now it's coming from the database, not from the bind zone files anymore. And now that it's in the database, it's quite easy to make changes to the zone content. It's just making updates to the database. So you write SQL statements. You can even write your own front end, web front end, to manage the database. A lot of people, especially at ISPs, have knowledge how to do that with Python, Ruby, PHP, or other tools. Okay, that was the MySQL backend. And as the last backend to show, we will use the remote backend here. And I've chosen the Unix pipe backend here in Python. And let me show how that looks like. So the remote backend is especially interesting if you have some database with other configuration or other information like email addresses or certificates or something like that, and you want to create DNS content from such a database. So here we launch the remote backend, and the connection is a pipe going to a Python remote tool. We have a look at the Python program, which is a very, very simple example program that can be found on the remote backend's documentation on GitHub. So it's just waiting for a query and then looks for whether the query name is Men&Mice.info and whether it's a SOA record, then it returns the SOA record. If it is of type any, it returns an A record and a SOA record. So basically we have just a a zone here with a SOAR record and an A record, nothing more, just to keep it simple. Now, these are the results of the any query, and at the end we just initialize the remote backend library, which makes programming such a remote backend in Python quite easy. There's also similar libraries for Ruby and other programming language. I'm starting PowerDNS, and now I'm sending a query to the machine. And here is the SOAR record. This is the SOAR record now coming from the remote Python backend. This is the A record. And if I'm asked for something that does not exist, I'm getting an NX domain as being expected. So there's no www.men&mice.info served by the Python script. So we get an NX domain back. Now I do a small change of the Python script just to demonstrate that it's really coming from the Python script and not some zone file. What I'm doing here is I'm changing the time to live on the A record, and I'm also changing the IPv4 address on the A record. Saving my Python script and doing the dig again. We don't see an update. What happens here? This is because of caching. PowerDNS still has the old data being cached because this has been queried already. So I'm restarting PowerDNS and sending the query again, and now we see the new time to live of 600 seconds and the new IPv4 address. So that was the remote backend. DNSSEC. PowerDNS has a full DNSSEC implementation, meaning that it can serve DNSSEC signed zones. So it can serve, for example, DNSSEC signed zones that are signed by a different tool. You can use OpenDNS, you can use DNSSEC signed zone or LDNS signed zone to serve an already fully signed zone into PowerDNS. That's possible. And that is maybe needed if you have certain extra security requirements and you cannot keep the keys on your name server. However, PowerDNS is also a full zone signer, so it can do all the signing itself. It also has key management. It doesn't do key rollovers automatically, but it makes it really easy to do your own key rollover scripts. And you can export and import the keys from other name servers. For example, if you already have keys in the bind format, you can import them into PowerDNS, or you can export them. And there is a simple but very powerful command line interface, and I would say it's among the simplest to use DNSSEC implementation among the DNS servers out there. And there's one unique selling feature for PowerDNS, which is the DNSSEC NSEC3 narrow mode. Now, DNSSEC uses NSEC3 records to provide authenticated denial of existence, which is a fancy way to say it proves that DNS information does not exist, and it does that in a way that it's cryptographically signed. Now, there are different options how to do this. There is the NSEC record, which is the standard and easiest one, but that allows zone walking, basically allows anyone from the outside to list all the contents of your zone. There's NSEC3 that was created to solve the problem of zone walking, but NSEC3 using hashes makes zone walking hard, but not impossible. It's still possible to list the zone and walk the zone. It's just much harder, but an attacker with some time and money will be able to do that. Now, the NSEC3 narrow mode solves the problem with normal NSEC, normal NSEC3, by using a little bit of white lies when answering to negative answers. We'll have a quick look into that. So first, NSEC. On the top here, we have a snippet out of a zone file. We have example.com, SOAR record, NS record, and 3 A records. A records being A example, D example, and G example.com. And if we use NSEC records, we see that every time the domain name on the left-hand side changes, we have a new NSEC record pointing to the next name in line in an alphabetical order. So we have example.com pointing to a.example.com, A pointing to D example.com and D pointing to G example.com. And that is the property that makes zone walking so easy, because from the outside, in order to list all the content of the zone, an attacker just needs to send one query. Doesn't need to be a query that can be answered. If there's a negative answer coming back, the NSEC record in the negative answer tells the attacker which name exists, and then the attacker just needs to follow the links to the next names. And the last name, in this example, the gexample.com, points back to the beginning of the zone, example.com, so it goes around and it's easy for an attacker. So NSEC3 was a solution, or is a solution by the IETF for this problem. And instead of working with the domain names for the NSEC record, it works with providing hashed domain names. So here in this example, we have a hash of aexample.com pointing to the hash of dexample.com, and the hash of dexample.com, NSEC3, pointing to the hash of gexample.com, and so on. Now the problem here is that an attacker can still work the zone and can collect all the hashes. Now all the domain names behind the hashes are not obvious, but an attacker can then, after working the zones and collecting all the hashes, start brute forcing these hashes. And with modern hardware, especially with GPU, with graphical processing units, it is possible to break these hashes in NSEC3 hash change in a matter of days, at least most of them, like 50 or 60% of them. So NSEC3 alone is no help to prevent zone walking, it just makes it harder. Now, what is NSEC3 narrow mode? NSEC3 narrow mode, if the DNS server, in this case the PowerDNS, needs to return an answer, and this answer is a negative answer, it then sends a white lie telling just exactly the name you are querying for, or the attacker is querying for, doesn't exist, but the name immediately before the name being queried and the name immediately after the name being queried, that exists. So here we have a hash of aexample.com and pointing to the hash of cexample.com, and the question was for bexample.com. So this tells the requester that bexample.com doesn't exist, but A exists, aexample.com exists, and cexample.com exists. And there is an NSEC3 record proving that B doesn't exist. Now, in the next query, if we ask for cexample.com, we're getting a different negative answer. We're getting an answer that actually B exists now, and C doesn't exist, and D does exist. So it's always the name above and the name below. That is possible because every DNS query is independent, and in between queries, the zone could have changed. So even though this record doesn't really exist in the zone, PowerDNS can pretend they exist, and that gives an infinitive number of names in the zone. And if someone would like to list that zone, that person would need to send an infinitive number of DNS queries to just enumerate all possible names that exist in the universe, and that's not possible. It takes way too much time. So when to use NSEC or NSEC3 or NSEC3 narrow mode? You use NSEC if you have a simple zone, a zone with predictable content. Like if you have a zone that has just and SOA record, DNS records, and maybe 2 MX records for your mail, and then 1 A record for the website. Now, that's so easy. The attacker will know that the zone exists, and he might just guess that there is a dub entry in there. So there's no real sense in using NSEC3 or NSEC3 narrow mode here. You use NSEC3 if the zone changes quite often, or if you have changes that you want to protect for some days or weeks, because then the attacker would need to go through all the work in collecting the hashes and then breaking the hashes one by one. And using just NSEC3 is no guarantee that the data will still be private, but it helps a little bit. And use NSEC3 plus narrow mode if you have some sensitive content. One example of sensitive content is the new OpenPGP key or SMIME proposal in the IETF, where OpenPGP key materials or SMIME certificates are stored in the DNS, and the key lookup, that is the domain name for these records, is the email address of the owner of that PGP key or SMIME certificate. So in these zones, we will have email addresses, and of course, spammers would like to know or easily list the email addresses in the zone. For these kind of zones, it really makes sense to use PowerDNS, NSEC3, and narrow mode. Be aware that if you use NSEC3 in narrow mode, that requires live signing, because PowerDNS creates these white lies NSEC3 records on the fly, because there is a definite number of these records that cannot be pre-created, and all these NSEC records need to be signed. In order to be able to sign the on-the-fly created records, the DNSSEC keys needs to be present on the authoritative server, on every authoritative server, so on the master and on the slaves. That might have security implications of its own. So there's no free lunch. And now we have a demo on doing DNSSEC with PowerDNS. So first, we have a look at the PowerDNS configuration file again. And I'm going back to the bind backend here. And for the bind backend, we have to specify the bind DNSSEC database, which is an internal PowerDNS database that stores all the DNSSEC configuration. And then I changed the default DNSSEC key sizes here, the key signing key and zone signing key. That is completely optional. If you don't do that, you use the standard RFC recommended values. This was just an example on how DNSSEC parameters can be tweaked in the PowerDNS configuration. So next I need to create the database, the PowerDNS DNSSEC database, which is where PowerDNS stores the key information, and that's an SQLite database. Now it's created, and then I start PowerDNS. And we have our zones already loaded. The 3 zones are loaded. Are still the same zones as before. And if I send a dig query with DNSSEC to Men&Mice.info, we will see there is no DNSSEC at the moment. The zone is currently not signed. So we get back the SOAR record, but there's no signature on this SOAR record. Now let's sign the Men&Mice.info zone. That's just one command: pDNSSEC secure zone, name of the zone, and then PowerDNS will create the keys, will sign the zone, create the NSEC records, and we are all done. So now the zone is signed. It's that easy. Still, the running instance of PowerDNS still has the unsigned zone because of caching. So a quick restart, and now we see the signature. So at the top we have the signature for the SOAR record, and below we have the SOAR record. Be aware that PowerDNS does not increment the serial number, so it's still the same serial number. So if you do signing this way, make sure that you first increment the serial number if you have traditional style slaves that look at the serial number. And here we see the NSEC record, so the zone by default is NSEC signed. Now I want to change it to NSEC3. That is done with the pDNSSEC set NSEC3 for the Men&Mice.info zone, and in quotes I give there the NSEC parameters, which is the hashing algorithm, the flags of 0, 250 iterations, and then the shell escape here just creates 16 bytes of random data for the salt. So now the zone has been changed from NSEC to NSEC3. We now need to rectify the zone, which creates the NSEC3 chain. That has been done. And now our Men&Mice.info zone is NSEC3 signed. Now I get a server fail here, which also is a result of caching. So I need to restart or reload the PowerDNS to make sure that it knows about the changes. And here we now see that we have NSEC3 denial of existence with the hashed domain names. Doing NSEC3 narrow mode is the same parameter as before. I'm doing that in a moment, just with the additional argument narrow at the end, just right in the demo window. Doing rectify and doing a quick restart. And now, if I send a query, we'll see that the hash names are pointing to the direct name before and the direct name after the name being queried. And we see that the hashes are almost the same, just the last digit is different. So it's 72 to 74, and the one is lowercase, the other one is uppercase, but that doesn't really matter because in DNS everything is case insensitive. So that was the DNSSEC signing demo. And now to the Men&Mice Suite PowerDNS support. Because PowerDNS is a so nice product, we have decided at Men&Mice that we want to support PowerDNS with inside our Men&Mice Suite. And we have created a generic Python DNS controller. And currently it supports the MySQL backend. But being a generic DNS controller that is written in Python, it can be adapted to serve the other backends as well. So if you have requirements for PostgreSQL, Oracle, SQLite, or GeoIP, or any of the other backends, just let us know. And maybe if you are a Python hacker, you can even work on it yourself, or let us know that you have interest, and we will consider implementing it. Feedback is always welcome. So last demo for today is showing the integration of PowerDNS into the Men&Mice Suite. And installation is also quite easy. So first we have a look again at the PowerDNS configuration here. I'm now back to the MySQL configuration. And there's nothing special in the PowerDNS configuration because PowerDNS is completely unaware that it is being managed by the Men&Mice Suite. Then there is the configuration file for the Men&Mice server controller, the DNS server controller, and it has a configuration that is pointing to the Men&Mice generic PowerDNS controller. The controller is written in Python 2. So if you have a system that already has migrated to Python 3.x, make sure that you install the tool with Python 2. We might provide a Python 3 compatible generic controller in the future. And this is the script again. You have to tweak the script a little bit. For example, you have to put in the login information to your database and whether it is a native PowerDNS zones or whether it is master-slave configuration and the log file. So now I start PowerDNS, then I start the Men&Mice server controller, remote. And if you wonder about these SV commands, as we start that is run it, and we will have a webinar just showing how run it can be used to keep your servers, the DNS servers and other servers up and running. That will come later this year. So I now have switched back or over to the graphical user interface, the Men&Mice Suite. Here I'm adding a new DNS server of generic type. And now it shows under DNS server, and we see already the 3 zones that I have used in the demo. And I'm creating a 4th one, the Men&Mice.com zone, selecting PowerDNS 01 example.com as the master server, and now it works just like the bind or the Microsoft DNS that can be managed by the Men&Mice suite. So I'm putting in here an A record and quad A record into that zone and an MX record just to have some content to query. Saving that back. This data is now saved back directly into the PowerDNS database, and the PowerDNS instant running can make use of it. So back on the command line, and here I'm sending a dig to my PowerDNS server, asking for the just created www.men&mice.com resource record, and we see it works. I'm getting an answer back, and also I'm getting the IPv6 address back. So that was easy. So that is almost the end of the first part of the PowerDNS webinar. I would like to point out our upcoming trainings, and we have this question and answer coming after this. So the next trainings we offer is the intro into DNS and bind in the US in Arlington near Washington DC, and that training is already confirmed. It's end of September, beginning of October. It's the 2-day intro and then the 3-day advanced containing DNSSEC and DANE. And then in German language, we have in October a DHP workshop that is currently not confirmed, but there are seats open as well. And at the end of October 26th to 13th of October, we have the DNS and bind in German language, and that is already confirmed. It's 3-day intro DNS and bind, and then 2-day DNS security and DNSSEC. And the upcoming webinars, the second part of the PowerDNS webinar will be on 17th of September. So in roughly 2 weeks, where I will show the master and slave and supermaster functionality of PowerDNS, some Lua scripting magic, the HTTP API, and some tools that come bundled with PowerDNS. More later this year, we have then a webinar on keeping DNS servers up and running with Runit, a new tool that I'm using for my installations, and you have seen that already here in the PowerDNS webinar, and I will show you how that works. Quite nice. We will then talk about DNS tab in a different webinar about how to have a deep look into the internals of a DNS server while it is answering queries. Featuring Unbound and Knot DNS that both support this new technology. And then the big release, the new Microsoft 2016 DNS server, which, from my point of view, is a big leap forward. It has no views, it has response rate limiting, it has access control lists, and much more that we have missed in previous versions of the Microsoft DNS server. It's now all in there. And at the very end, we have an update on DNSSEC and DANE, about new software implementations that make use of DNSSEC and DANE, about the adoption in the market. There's a lot of going on, especially here in Germany, and about new emerging internet standards around DANE and DNSSEC. Whew. I hope that was interesting. Questions? Peter, do you see any questions?
No, Carsten. You left us speechless here, so there are no questions yet. We can give it another minute or so. Can you maybe, Carsten, explain the kind of typical use case for PowerDNS, where it is mainly deployed these days?
It's very popular at ISPs because of the SQL database backends. Because ISPs, they already have web interfaces for their customers, where the customers can do DNS hosting and maybe DNS registration and maybe other stuff, web hosting. So integrating PowerDNS in these existing web interfaces quite simple. So PowerDNS is popular there. It's also very popular with administrators that do DNSSEC signing, especially bulk DNSSEC signing. because it's so easy to manage DNSSEC with PowerDNS. And third, because of the narrow mode, it's now popular with people that are deploying the newer DANE technologies like the OpenPGP key or S-MIME that I pointed out.
Okay. So are you keeping the best part for the second webinar?
I wouldn't say the best part. I mean, there was already quite good here. This is this was basically the most important part, and the other one is more advanced, but still interesting.
Very good. So I see no further questions here.
Oh, one is coming in.
Yeah.
What is the performance impact of the Python integration? Because PowerDNS does the caching, of course, the very first query, as with other backends, it can be a little bit slower because PowerDNS needs first to launch the Python script and the Python engine backend and wait for the answer to come back. But once the answer is there, it's being cached, and then it's as fast as with other name servers or the other backends coming directly from memory. Of course, depending on your use case, you might need to tweak the caching in PowerDNS, how long it is cached, and so on and so forth.
Very good. So, Carsten, there are no further questions. So thank you for your presentation today. And I'm looking forward to the next part on, was it September 17th, part 2?
Yes.
So I'm hoping to see all of you there. And you can find the recording for this webinar at our website shortly. So thank you all and have a nice day.
Have a nice day. Thank you, Peter.